Our next speaker is Peter Shannon, Managing Director of Levitate Capital. Peter Shannon has built his career as an entrepreneur and venture capitalist, focusing on transportation and logistics technologies, including unmanned systems and aerial mobility, and their application toward positive impact for the world's growing megacities. In addition to investing, Peter is active in the aviation community around emerging standards and the intersection of regulatory and technology issues critical to enabling high-scale adoption of future aerial mobility systems. He is an appointee to NASA's Aeronautics Research and Technology Roundtable, a part of the National Academies of Science, Engineering, and Medicine, which convenes leaders from government, industry, and universities to address critical issues related to the nation's aeronautics research agenda. Peter is also involved in the FAA's Commercial Drone Integration Pilot Program as an advisor to one of the program's drone test sites. Prior to his current work, Peter was at Levitate Capital and Atlas Venture, investing across transportation and sustainability-related technologies with a focus on the intersection of software, autonomous systems, and geospatial data on the automotive sector. His past entrepreneurial experience began while an undergraduate when he co-founded iResponse Inc., a company that pioneered computer eye tracking systems. Peter holds an MBA with high honors from the University of Chicago Booth School of Business and a BS with distinction in systems engineering from the University of Virginia. Peter started flying when he was 19 and actively maintains a private pilot certificate with instrument rating. His presentation today is an investor's perspective to the opportunity in advanced aerial mobility. Please welcome Peter.
I'm going to talk a little bit about aerial mobility in the context of transportation in the megacity. First, a little bit about myself. I've been a venture capital investor now for about 13 years. I'm an engineer by training, systems engineering, applied mathematics, computer science. Out of undergrad, I co-founded a software company that was tasked with exploring how we could teach computers to track human eye movements. A very interesting learning experience to understand how technology can be applied to new business ends, especially for a young undergraduate. After about 7 years of software engineering experience, I went and did my MBA at the University of Chicago, and coming out of that, thought I would go into the venture industry to see if I could learn that area and see what it held. Joined a firm called Atlas Venture and was there for about 5 years, and I was on a team that spanned looking at deals all across technology. I developed an area of focus in sustainability, so renewable energy, transportation, batteries, electric motors, and the like. During that time, I moved to a firm in 2010 called Levitate Capital. I was there for about 7 years and really narrowed my focus into the transportation sector because I saw quite a diverse set of opportunities that could be addressed with new technology and transportation. And in particular, there's a very interesting intersection between innovations in materials and areas where I had been looking as a sustainability investor, and how software is having an impact on transportation. And the two really represented a convergence of so many of the things that I had done in my education and in my career, and it became the focus of my investing. At the same time, I saw a parallel set of things about to happen in aviation. So the same things that we saw driving change in the automotive industry, electric propulsion, autonomous systems, mobility as a service, we're beginning to have a big impact on aviation. We could see the telltale signs of that. And so a little over a year ago, I began to focus exclusively on finding the technology opportunities that are in this space. And when I went into it, I thought it was going to be a relatively focused area, something that would be fairly manageable to cover. And I've been astonished with the amount of actual true activity that's going on in this space. I think I've seen upwards of 200 companies looking at this space, going into the supply chain that are serving vehicles themselves, and infrastructure and systems that support the operation of these vehicles in real-world applications. So, to start talking about aerial mobility and the opportunities that we see, and me as an investor, I look at this from the perspective of how do you build a portfolio of investments here in 2018 when we're very early in this sector's cycle. And I think to understand that and to understand the role aerial mobility can play in our transportation infrastructure, it helps to begin with a look at the history of transportation technologies and the role they played in shaping our cities and society. Studies looking back through recent history as well as at ancient cities indicate that people's allocation of time to their daily commutes has remained strikingly constant over time, at about 60 minutes budgeted per day. Based on this and the transportation technology available at the time, whether foot, horse, or by machine, communities and cities were shaped and bounded by these limits. On the map here, center right, you see the ancient Gothic quarter in the center of Barcelona. The primary purpose of a city is to enable interactions between people. We value these interactions because they represent the basis of social and economic progress. Thus, a city is designed to provide both maximum proximity as well as maximum mobility while utilizing the technologies of the time. Both ancient cities and today's most modern exhibit this trait. This is a photograph of that same quarter in Barcelona. You can see advanced civil engineering for the time to create dense housing around foot traffic transportation fabric. However, the size of cities was limited by what the transportation infrastructure could support. When transportation improved, cities grew and were also shaped by its characteristics. The Industrial Revolutions, steam and electric power, iron and steel, brought rail and streetcar transportation, which enabled cities to expand their reach well beyond typical foot or horse-based mobility distance. Railroads connected resources outside of cities to the residents within. While the walking-based core of cities remained, the new city growth around it took on a different shape, clustering around the rail lines branching out from the city center, as you can see from this streetcar line map of Cincinnati from 1911. Henry Ford's perfection of mass production of the automobile in 1908 transformed it from a novelty for the rich into a consumer product, and one that could be afforded by the workers on the assembly line, part of a new consumer class in America. The introduction of the mass-produced automobile in the early 1900s again had a profound transformative impact on cities. It differed from rail transportation in that it was individually owned and thus capable of on-demand, point-to-point transport over any available roads. The independence and convenience of rapid automobile transport proved extremely popular, and cities expanded again, this time filling in areas of countryside not well served by fixed-route rail networks. The idealized vision of the automobile-enabled lifestyle was embodied in the suburbs. Living outside the city, but being able to access it quickly and conveniently, a family could have clean air, space, and a safe and wholesome environment for children. Automobile manufacturers marketed this lifestyle, and the love affair with the car took root in American culture. However, there were unforeseen consequences. The automobile's growth in the 20th century coincided with global industrialization process and a population boom never before seen in history. Population increased from 1.6 billion in 1900 to 6.1 billion in 2000. And urban population increased from approximately 250 million to 2.9 billion during the same time period. Since the turn of the century, urban populations have continued to explode, advancing further to 4.1 billion people, meaning that a majority of the world's population now lives in cities, a first in recorded history. Throughout this period, road congestion has increased, despite massive infrastructure projects to increase capacity. It has been observed that increasing road capacity does not relieve congestion. Rather, in response to the additional capacity, road utilization increases until congestion returns to the prior levels. With 5-hour drive times to cross Jakarta and 24-hour traffic jams in Sao Paulo as anecdotes, and data to support the ongoing worsening traffic in the face of urbanization and more people affording automobile ownership globally, the conclusion is that road transportation is not scaling to megacities. We have effectively reached the scaling limit for this technology. So what are we doing about this? Well, entrepreneurs have unleashed a wave of creativity, harnessing modern technology to deliver improvements, alternatives, and solutions, and in the process, creating tens of billions of dollars of value in the last decade. We're using information technology and data to make more efficient use of roads and broader transformation resources. We're creating new business models such as ride-sharing that show users the advantage of mobility as a service. And we're easing spontaneous consumer access to mobility services through the smartphone. And most interesting to us in this room, we're building new vehicles made possible by electric propulsion and autonomous systems. So when we step back and take a look at the continuum of transportation advances over history, we see we're in the midst of a new technology revolution. This one driven by the penetration of software into the physical world, driving the same improvements in capability and productivity gains that we have seen it make elsewhere. But notice that our timescale is logarithmic. This revolution is happening much faster than transformations of the past, for several reasons that we'll explore later. And we're also seeing a change in consumer behavior as well. People are putting together complex multimodal routings, courtesy of software-enabled services, that they wouldn't have embraced as feasible just a few years ago. This is important to us in that it lays the groundwork for the introduction of new modes of transport, such as advanced aerial mobility, allowing it to be integrated and to deliver greater utility. So now, turning our attention to the role aerial mobility plays in overall transportation, let's look at its progression. From the day Charles Lindbergh landed the Spirit of St. Louis at Le Bourget in 1927, people have dreamed of when the spontaneous freedom of flight would be fully realized, to move around the world as they wished. That dream has remained elusive for nearly a century, with participation constrained to mass aggregation on limited, scheduled air routes, and wealthy enthusiasts braving the expense and complexities of private aviation. Nevertheless, at the time, Charles Lindbergh's crossing of the Atlantic was a pivotal moment that inspired the world, bringing a wave of capital, entrepreneurs, and engineers into the industry. The shared vision at the time was that soon everyone would be flying their own aircraft, like driving a car. During World War II, advances in aircraft design and manufacturing, and combined with the large number of trained pilots and even larger number of people who otherwise exposed to aviation through their military experience, raised expectations for a domestic revolution in the use of personal airplanes. It was anticipated following the war there would be demand for hundreds of thousands of airplanes as soldiers returned and adopted aviation for everyday mobility. Ads during the war reflected this expectation as general aviation manufacturers prepared themselves and the public for the coming new era in flight. General aviation industry sold a record high 33,000 aircraft in 1946. However, the contraction in general aviation aircraft sales came about suddenly and violently. In 1947, the number of aircraft sold dropped to less than half of 1946 total, and then dropped by more than half again in 1948. The number continued to drop until 1951, when the total number of general aviation aircraft sold reached 2,300. After a modest recovery in the 1960s and 70s, general aviation aircraft shipments stalled and have stagnated for the last 40 years. So, general aviation's failure to scale in the 20th century. We can relate this failure to what really was a cycle that started decades ago, in that aircraft manufacturers were unable to sell enough aircraft to support ongoing research and development in the face of the highly regulated safety environment. But beyond that, operating small combustion-powered aircraft proved to be simply too expensive and complex to bridge into mass adoption. Certain fundamentals in the technology were just not there yet. So to sum it up, flight in the 20th century proved not to scale down well to personal transport. But history is replete with great ideas that were before their time. When we apply modern technology to flight, we see how it can upend the core assumptions around the aircraft, its economics, safety, and usability, and moreover, the overall transportation system in which it will operate. This technology has created a pathway to our much wider use of flight, and we are already seeing the results today. Technology, in fact, is redefining flight. I see the opportunity as defined by three technology megatrends: propulsion electrification, autonomous systems, and mobility services. which will manifest in 3 broad platforms: advanced drones, hybrid electric and fully electric fixed-wing aircraft, and electric VTOL, which, when they mature and barriers to adoption are lowered, will be applied in a wide spectrum of use cases in cargo, logistics, transporting people, and in other areas. However, the pathway to redefining aviation with 21st century technology is a complex one. There are sharply contrasting cultures between the people who are driving technology innovation and the community that has tested, refined, and driven aviation to its current levels of safety and maturity. Each community has a lot to learn from the other. Success will require a deep understanding of the aviation domain and an ability to discern where the early wins are and what precursors need to be in place for introduction and scaling of new air vehicles. At a very basic high level, the vastly lower operating cost of hybrid electric and fully electric aircraft can open up new markets, yet can largely be implemented within today's infrastructure, airspace, and operating environment. Drones today fly within constrained parameters, but with improved airspace management and security measures, will be performing much more far-ranging and advanced operations. Air taxis enabled by electric VTOL technology will benefit later from the pioneering work done by the drone community, while layering on their own additional capabilities and passenger mobility infrastructure. So when I look to compare history with our present-day aspirations, yes, I see fundamental technology changes that convince me that we will build advanced aerial mobility vehicles. But moreover, I'm encouraged by the fact that the manifestations of the technology and its end use cases are so diverse that despite the great complexities of societal adoption of this new transportation capability, and while it will complement but not solve road transportation, it now appears inevitable that it will play a crucial role in our future transportation infrastructure.